Are you curious about how computers actually work? In this video, we delve into the intricate mechanism of how a computer actually works. We will learn the key components of a computer. All computers are the same. They have a CPU, they have RAM, they have a motherboard, and they have storage, which would usually be a hard drive or SSD drive. I will take you through each one of these. So, even your smartphone is a computer. The only difference is that the components compared to these are all built in. It has RAM, it has a processor, so it's all just different sizes, but they all do work the same. So, what is a computer? A computer is an electronic device that processes data, executes instructions, and performs tasks. The CPU, think of it as the brain of the computer. It processes instructions from the programs and performs calculations. It's made of millions of tiny transistors. So I have one over here that's already removed from a computer. I'm not sure if we would be able to see this. I'll search for a picture on Google and then just post it in this video. So on it, you would see the type of processor it is. This one is an Intel processor, and the one on this board is an Intel Core i3. This one is a dual core Pentium. Now this one is a Pentium 4, 3.2 gigahertz. The gigahertz is the clock speed of the processor. The clock speed determines how fast the processor runs. Nowadays, like I showed you on this one, it says i3. This one is a Pentium. This is a single core processor. This one is a multi-core. I think it has two cores, so it can simultaneously run programs on the two cores, which is built into the single processor. On these processor, they'll have a cache, and cache is a storage for the programs to when the programs run, the processor would store some of the information or data on the cache, so it's easy accessible and makes it helps the processor run the program faster instead of reaching for stored information or data on the hard drive every time it needs it. There's different cache on it, but I won't go into that detail. You can surely Google that for more information if you would need to really understand the nitty gritty of the central processing unit or CPU. Let me just move that one across. I hope you can see this. So on your motherboard, it will have a little compartment for it. You would just there's a little clip over there that you would press and move to the side. It will release like that, and as you can see, the whole bracket goes back, and then you can remove the central processing unit like that. And the back, it's filled with small pins. The older units actually had pins which you could bend, which would make it much more hazardous to handle and um, more prone to damage. This one's is just printed circuit, and the pins are on the side where the central processing unit would be placed on. So just be careful not bending those pins, because if you do, it would most likely cause it not to function. You would see that it has this little cutouts on it, so the processor can only go in one way, and it will only fit on the specific boards that was made for the specific type of processor. You just close it back up like that, slide it back, slide it forward, push down the clip, and there we have it. From there, you would apply some thermal paste, and to keep the processor cool, you'll install the heatsink and fan assembly. I'm sure you can remove the fan from the heatsink. So if the fan does break, you can remove the fan and install a new fan on the heatsink. The heatsink is to conduct all the heat from the processor, and the fan would just cool the heatsink that just puts on like that. That would prevent the central processing unit from overheating. There we go. The memory, or random access memory, or RAM for short, is short-term memory and stores data and instructions. The more memory you have, the more tasks your computer can handle. Over here on the motherboard, you have the slots. Depending on the motherboard, you would have a number of slots for RAM. This one has two, but I have seen ones with four slots for RAM. This board supports DDR3 RAM. It starts from DDR1, and I think the newest is DDR4. Like I said, this one is DDR3. So over there you can see that's a DDR3 RAM. So what the RAM is used for is just to speed up the computer. So because RAM is a much faster storage device than a normal hard drive, the central processing unit stores the information. If you open a program, it will store some of the information on the RAM, which is needed for the program. So the more RAM you have, the more programs you can run simultaneously. The RAM it does not store information permanently. So after you do power it off, anything that was stored on the RAM would be removed. I think the minimum nowadays for your Windows 10 and 11 machines would be about 4 gigabytes. Minimum for Windows 10 is like 2 gigabytes, but I would suggest like having a minimum of say 4 gigabytes to run the program. This is a DDR2 RAM. You could see the cutouts was round compared to the DDR4, the DDR3, which is square on the sides. That little leaf over there, or whatever you call it, someone can just put in the comments what it is called. That would not be on the same spot, so you would not be able to install a DDR3 RAM in a DDR4 machine, or a DDR2 RAM in a DDR3 or 4 machine, or DDR1. They also have clock speed. Like this one is 800 megahertz. I think this one is 1333 megahertz, which would be 1.3 gigahertz. RAM is crucial. It's short for random access memory. It stores instructions that is needed by the CPU to complete tasks. So the DDR stands for double data rate. It was an improvement over the SDR RAM or SDRAM, which was single data rate. The higher the clock speed, the better the RAM. I'm not sure it will be that noticeable, but I'm sure for the game, that's a very important thing to look at when you are purchasing RAM. So they wouldn't just look at the size of the RAM. If they wanted to add 4 gigabytes of RAM, they would also look at the clock speed when purchasing RAM. Like I said, depending on the motherboard, if it's a DDR supported motherboard, it will only support DDR3. If you did want to upgrade to a DDR4 or DDR5, you would have to change the motherboard to change it all. The storage, or the hard drive or SSD drive, is the long-term storage or lifetime storage, where you would store your data or your files or your programs and your applications and your operating systems. Hard disk drives are mechanical with spinning disks, whereas the solid state drives do not have any moving parts. This would be a 3.5-inch hard drive, actual size of the hard drive. This one is a 250 gigabytes of storage, and it is a hard disk drive. Their performance is usually their storage space, and then also they have a RPM, the speed of the disks inside. They are mechanical, so they can fail, and they do fail. They do get slow. You also do get a thinner, if you look at the two, 3.5-inch hard drive. So it's just the height difference in the two. But this one is actually 500 gigabytes. And I said this one have a speed of 7,200 RPMs, and this one does not actually show it. It does give you some other information such as number of cylinders, 16,383 cylinders, 16 heads, 63 sectors, and that has to do with the disk inside and how it um, stores its information on the hard disk drive. This is also a hard disk drive. You for the laptops and your smaller form factor computers, which is the 2.5-inch hard drive. Let me just check some specs on this one for you. This is a 160 gigabyte hard drive. It has a SATA speed of 3 gigabytes per second, which the others didn't show, but I think they would be around about the same. And there's a disk speed of 5,400 RPMs. So this one spins faster. So this is also still a mechanical hard drive, or it uses the disk with the read and write head inside, but just very small and compact. Yeah. So from there, we moved we actually moved to something like this, which is a solid state drive. And instead of using the disks inside, it has electronics. It has like your little ICs and stuff. I haven't actually opened one, so maybe one day if one fails, we can actually open one on the channel and have a look inside. They are much faster, and they are a great upgrade. Like I would suggest a solid state upgrade instead of a RAM upgrade. But if you can do both, I would suggest that. If you did have a slow PC, in the future I'll make a video of actually doing a hard drive upgrade to a solid state, and we can have a look at the benefits thereof, and also do a memory upgrade and compare which is best. Um, so this would not have a RPM reading because there's no disk inside, but it does have this one does not have it on. But their speeds, their SATA speeds is usually about 6 gigabytes per second compared to this one that's 3 gigabytes per second. They plug into this little SATA inputs over there on your motherboard. The motherboard or the main board connects all the components together. It will house your RAM, your CPU. It will have your inputs and outputs. So things like your video, like your motherboard would have your onboard graphics, so it would supply your VGA out, or this one has a display port as well. It has your USB ports that would have a built-in LAN, which is I think 1,000 megabits per second port. It will have USB 3 depending on the motherboard, and it has a sound out and a mic in. So the motherboard is just to house everything. It brings everything together. It does also have its own firmware on, which is usually the BIOS. I know the newer devices like this would have a UEFI firmware on it. Connects all your components, such as your inputs and your outputs. The firmware on your motherboard would allow you to interface your hard drive and have your CPU talk to all the different components on your motherboard. So that's why if when you go onto your firmware, such as your BIOS, you would be able to see your different hardware you have on your computer, the amount of RAM, the CPU you have on your motherboard, and the specs of each of that hardware components. The motherboard also allows you to expand the computer itself, like installing little PCIe cards like this one, which is a Wi-Fi card. It will plug into the little PCIe Express port over there, and that would now allow your motherboard to have a Wi-Fi interface, and it will also give you the capability to install a graphics card if you did need an external graphics card for HD graphics. A lot of the motherboards nowadays do support higher definition graphics. When the computer powers on, the BIOS or the UEFI firmware initializes all the hardware. It then loads the operating system from the hard disk drive or solid state drive into the RAM. The CPU then fetches instructions from the RAM and processes it. It performs calculations, makes decisions, and sends instructions to other components in the computer. To power it all, you would need a power supply. That's how it looks. I'm sure you guys have seen one before. That has the input that plugs into the wall. And from there, you would have all your outputs that goes to your motherboards, your hard drives, and your CD drives, CD-ROMs, which I think some of your graphics card would also need some direct power input from your power supply. Why you do need a power supply is because all your components in your computer needs different voltages. So in South Africa we have 220 volts AC input, and this power supply converts that to a 12 volt output. It converts it to a 3.3 volt output. I think the other one is like 5 volts. So different components needs different voltages, and that would obviously be a DC output from the AC input. Like I read here on this thing, I think it was that. Okay, they didn't actually show it. Yeah, it does. So, like your hard drive over here shows the your DC supply for this hard drive would be like 5 volts DC. I'm not sure if you could see that. If I did miss anything in this video, feel free to comment on the video. Thanks for watching. See you next time. Here I'm Jason Does IT.